In this session of looking at Svantek Supervisor software, we're going to look at how we create a setup file that has the configuration for how we want an instrument to make the measurement for us. As an example, we're going to connect an SV104 noise dosimeter to our PC and follow the steps through to create an appropriate setup file. So at the moment we don't have any instrument connected to the PC at the moment. So switch on the noise dosimeter and connect with the USB cable to it. Okay, and after a few seconds you'll see that now a couple of things have changed on screen. First of all, the highlighted instrument now becomes the SV104 to signify that is our recognized and connected instrument. We see up here that yes, this dosimeter is connected, this is the serial number, this is the information about the connected dosimeter. So the first thing we notice is that the clock information is highlighted in red. This indicates that the instrument time is not matching our PC time. Maybe it's been changed from a different time zone, or maybe it's just gone out of synchronization, or maybe you've just taken the instrument out of the box and it was set for a completely different area. So the first thing to do is to synchronize both the instrument clock to your PC. We do this just simply by clicking on the clock icon here. And that's how easy it is to update the clock. The next thing that we need to do is to transfer the current settings from the instrument, shown over here, to our hard drive, shown over here, and then we're going to modify them, save them, and upload them back to the dosimeter and then activate them. That's the process. So to start this off, we highlight settings in the instrument file. This is the current settings that the dosimeter has, and by clicking on this button we'll transfer them to our PC. We now have a copy of the original settings in our PC. Now before we start work on this, let's actually just do one more job, which is to right click and choose duplicate, and we'll get a copy of the original settings here that we can work on, and that will leave the original settings file in case we ever need to go back to it. So here's our duplicate. Right click and let's just rename it. Let's call this setup basic. Okay, so we now have a basic setup in our local PC, and you'll see once we highlight this we have a number of tabs that have appeared over in the main part of the screen. Each one of these tabs controls how the instrument makes the measurement. We have a dosimeter tab, a measurement tab, a time history tab, a display tab, a general tab, an Autorun tab, and a recording tab. We're going to look at each of those as we go through this setup procedure. So let's look at the first tab, the dosimeter tab. Simply click on it to highlight it, and you'll see it's basically split into two parts. The top part of the screen are the basic settings. The bottom part of the screen sets the alarms that we can use for the instrument to warn us of excessive noise levels. Let's look at each of these in turn. In the basic settings here you'll see there are three columns labelled P1, P2, P3. These are the three user profiles that the dosimeter has, three virtual independent noise dosimeters that are able to act simultaneously for us to collect information. And you'll see we can just click and select from the various settings here what we want and how we want the instrument to measure. The first thing to be aware of is that profile 1 we consider to be the main or the master channel. This is the one that is the most significant for us. So this is the one that we want to contain the information that we most deem to be important. So here, for the sake of convenience, the dosimeters come with pre-programmed setups. So I'm going to just click the down arrow here and we'll see that there are some pre-programmed setups, and there are 3 user configurable setups if you want to alter to your own setup. So I'm going to choose the OSHA hearing conservation as the primary dosimeter in this instrument, and as soon as I choose from one of these pre-configured setups, all of the rest of the items below it here in this group are all set automatically. So in fact you don't have to go through and change these are all set instantly for you by just simply selecting the name of the dosimeter protocol that you want to use. So in the OSHA hearing conservation we set the main filter to be the A filter for the dose and the time weighted average values. We set our peak filter to be the linear or the Z weighted filter. We choose our sound level meter detector to be slow, a 5 dB exchange rate. Our criterion level is set to 90. Our cutoff or threshold level is set to 80, and the upper limit threshold time is set to 115 dB. And we can do this for each of the 3 dosimeters. So in our second dosimeter, let's choose the other OSHA setting, the OSHA PEL, permitted exposure level, and that chooses A, Z, slow, 5, 90. These are all the same as the hearing conservation, with one key difference. In the PEL measurements we use a 90 dB threshold to start our measurement, so only noise levels above 90 in this case will be included in our calculations. Again, 115 dB for our upper limit threshold time. And for the third dosimeter, a favourite is to choose the ACGIH measurement protocol. This also has the A setting but uses the C frequency weighting for the filter, the slow detector in the meter, a 3 dB exchange rate this time, so this is different from the 5 dB for the OSHA settings, and another difference is the 85 dB for the criterion level for our 100% noise dose with an 80 dB threshold. So this is how we simply select the basic settings for the instrument to make measurements pretty much according to the OSHA regulations in North America. If we want to, in this section as well, we can choose to have the alarms. The alarm function in the noise dosimeter is where when the readings reach the alarm conditions that are set independently for the dosimeters, the small red light on the face of the dosimeter will flash to warn that this has happened. Since we're looking at a basic configuration file at the moment, let's just disable these alarms by clicking, dragging and turning these off. So let's just turn all of the alarms off for the sake of simplicity. And that's all the settings taken care of as far as the basic noise dosimeters are concerned. Once we've finished all of the settings of the dosimeter, the next tab is the measurement tab. In the measurement tab there's just one group of settings here, and these control the function of the instrument, whether it operates as just a dosimeter collecting broadband results, or whether we bring in the octave bands and make frequency analysis at the same time if we have that option fitted to our instrument. The second choice here sets the start delay, the amount of time between instructing the instrument to begin and the saving of the first results. Start synchronization has a choice set here to synchronize the recordings to the real-time clock in the noise dosimeter, so we can collect information starting from these periods after an hour. Normally we would want that switched off so that we begin our measurements straight away. The integration period has some choices here for us. The infinity choice at the moment means that the dosimeter will collect an overall set of results from the time that we press start to the time that we press stop, whether that's 5 minutes, 3 hours or the whole shift. We'll end up with one run, which will have all of the information in. An alternative to that is to set a time interval, for example 1 hour. We could set 1 hour and a repetition cycle of 8. In this case, when we start our measurements, the instrument will collect 8 separate 1 hour readings for us over the whole of our shift. If we want the measurement to occur for a fixed measurement time, this is a good way of doing it, because when we have set this recording this way, once we start it, it will automatically stop after this number of cycles at this integration period. So we don't have to be there in 8 hours time to stop the recording. It will stop automatically. For the moment, let's just go back and choose the infinity setting and 1 repetition. So it's just going to do 1 single measurement. We want our integration for our LEQ to be on the linear setting. Our exposure time here allows us to tell the instrument what our nominal day's work shift time is. So this will typically be 8 hours for most measurements, but if you need to relate information to perhaps a 10-hour shift or a 12-hour shift, this is where you'd use the drop-down box to change the time and put it in as 10, 11, 12 hours. Anything up to 12 hours can be accommodated by just choosing here. So we're going to leave it as the standard 8-hour setting to begin with. Then finally we have a choice of either LEQ or L average values, or both. This setting is probably best left on the both setting, and then we have our true LEQ measurements and our L average measurements using the thresholds from the Dosimeter tab. This is all the settings that we need to consider for the measurement tab. Once we've finished with the measurement tab, we can go on to the next one, which is the time history tab. So the time history tab is what controls the sampling of the instrument during the run to collect regular samples of information for us according to the settings here. So this is split into 2 parts: the time history setup itself and the results that we're going to store for our time history profile. So let's look at this. We want the logging of these results to be on, so make sure that this is on. The logger step typically will start at 1 second, but can be any value from 100 milliseconds, 10 samples a second, right the way through to the longest sample is 1 hour. We have a wide choice of sampling intervals here. 1 second is the most popular one to set, so that's what we'll choose. In the logger name, we can edit that for a particular reason. If we want to use a particular file name to do our measurements, we can enter that here. The first measurement that we make will be called test, the second measurement that we make will be called test 1, and so on, with the instrument just incrementing the number after this main name that we've entered. So keep this simple if you're going to use it, but it does help to differentiate readings in different areas or in different locations. We want the summary results to be on. The summary results are the overall set of results controlled by the integration period that we saw on the measurement tab here. On this side of the time history screen we see our 3 columns, P1, P2, P3, and here this is where we can select which of the results we want the dosimeter to store. The best solution here is to click the All button and just store everything. Since there's so much room in the dosimeters, we don't have any worry about running out of space. It's always better to save all of the results, and then you can choose which ones you see after you've downloaded. So let's make sure that all of these are on. Once we've done all of this, this is the final settings that we need for our time history tab. Once we've finished with the time history tab, we'll go on to the display tab. Let's look at that now. Okay, this has two main sections, the modes and views down this side, and the actual displayed results that we choose to see on the instrument. The key here is to remember that these settings only control what the instrument will show us during the measurement rather than what it actually measures and stores. So on the modes and views we have a number of screens, a result list which we normally want to be on, the running sound pressure level, we want that to be on. In this case the file information, the file size and the file name is currently turned off. Let's just turn that on by clicking it. The instrument status here is the screen which shows us the battery condition and our likely remaining time. So that's always good to select that to be on. In the display profiles we have a check mark for profile 1, 2 and 3. Checking all of these makes the dosimeter operate in 3 virtual modes at the same time. For simplicity it's possible to turn off 2 of these settings to reduce the dosimeter to a single dosimeter for absolute simplicity where it's just showing one set of answers. The recommendation here again is to leave all these 3 checked so that it's on for all 3 dosimeters during the run. The current view settings here allow us to choose what we'll see when we first look at the display. So the main view is the result with just one single parameter on the screen at a time. This is a good choice. Since we said that profile 1 is the most important profile for us to look at, let's leave this choice as profile 1 as well. But it's also possible to select profile 1, 2 or 3 here. And then this chooses which result we will see when we look at the screen the first time. So perhaps a simple choice here is the instantaneous sound level, what the noise level is currently at the time we look at it as our beginning point for scrolling through the results. We have 2 further choices at the bottom on this side. The auto off selection on here means that after a period of inactivity on the keyboard the dosimeter screen will go off to save battery power. This is a good choice. The auto rotate choice here can be on or off. That just simply means if the dosimeter has to be fixed to the worker such that the instrument is physically upside down, leaving this on rotates the screen so that it's possible to read it whether it's the right way up or upside down. Okay, going on to the displayed results themselves, we have quite a long list here. There are probably over 24 separate results that are available in the instrument as a result of all the different protocols for making noise dosimetry measurements that are current around the world. Simply go through the list and turn on or off the readings that you don't want to physically see during the measurement. It's probably a good idea to turn off all of the units that you don't recognize, since if you don't recognize them the chances are they're probably not relevant to the task that you need to carry out. So let's turn off all of these and leave these values switched on. So you can see we've left the regular ones, the duration of the measurement, the peak level, the maximum level. We don't really need the minimum level. Sound pressure level is our instantaneous value, our current noise dose, our projected noise dose for an 8-hour standard day, and a projected dose if we've set the 10, 11 or 12-hour work shift. L average is the value with the threshold applied. LEQ is the true sound energy level with the 3 dB exchange rate. Down here the time weighted average is our normalized 8-hour value as required by OSHA, for example, and the projected time weighted average uses the exposure time for our longer work shift day, our 10-hour or 11-hour or 12-hour result. So these are the values that we want to be displayed on the screen when we come to interrogate the meter during the day. Bear in mind it doesn't matter what values you select here, all of these values will be stored and saved in the results, and you'll have access to them after download when you look at the results back in the data browser of Supervisor. If the dosimeter is fitted with the octave band option, then the Spectrum tab will also be shown along the top edge of the display here. In this case, there are two parts. The data side here enables us to pre-weight the octave band readings. Normally this will be the Z weighting, but it's also possible to choose the A or the C broadband weighting plus the octave analysis. Leave this on the Z setting unless you particularly need one of the other settings. On the display scale side, the dynamic setting here chooses the range of decibel levels that will be displayed on the screen. You have a choice from 120 down to a minimum of 10 dB to display the range. A good compromise is the 40 dB setting, and since the display will normally auto range as the noise levels move up and down, this is a good setting to maximize the display capability of the screen on the SV104s. Finally, you can turn on or off a grid across the screen to help visualize the sound levels. Once we've finished with the Display tab, we can go on to the General tab. Let's look at that now. There are four subsections in the General tab to do with the calibration, the measurement of statistical levels, the keyboard, and some auxiliary settings that we may need to consider. So let's look at these in turn. As far as the calibration is concerned, this is the target level that the dosimeter will try and set the instrument to read when you apply the acoustic calibrator. The default value is 114, but if you're using a calibrator which has a different level, 94 dB perhaps, or 90 dB, then just simply select it from the drop-down list by choosing it from the values that you see here. This information would be taken from the calibration certificate of the calibrator. Enter that value here as the target level. Our post-calibration setting is to consider the recalibration of the instrument at the end of the run. We want to make sure that that is set to either last file or files after the last calibration. Perhaps the last file is a good setting here. And since the dosimeter has a way of automatically detecting when the calibrator is fitted over the microphone at the start of the measurement sequence before the run begins, if we select the auto calibration to be on, then the dosimeter will recognize the calibrator and perform this auto calibration for us. So we need to make sure that that setting is on. In the statistical level groups, unless you specifically want these LN percentile values, then these are the standard ones and pretty much can be ignored. On the keyboard section here, the most important one is the first one here, whether or not the instrument will be locked once the measurement begins. It's possible to lock the dosimeter as soon as the measurement starts by selecting this to be on. Now, as soon as we start the measurement, the dosimeter keypad will be locked and the person wearing the instrument won't be able to tamper with it. If you want to lock the dosimeter manually before you leave it and go off, then you can leave the setting here to be off. The typical suggestion here is to leave this one on to be sure that the keypad is locked as soon as the measurement begins. If the keypad is locked and you need to go back to the instrument, then you need to have a way of unlocking it. So make sure that this is on and make a note of the sequence of keys that you choose to be the unlock code to get into the display and control the dosimeter anytime you want to. The standard default set is to press the down arrow, then the right arrow, then the enter key, and then the down key. But this sequence can be changed if you need to. Finally, the auxiliary settings here are not desperately important, but they're here for your convenience. Warnings whether or not the logging has been disabled, indicating a warning if you choose to turn the dosimeter off and didn't mean to. Gives you a chance to change your mind. You can change the comment text file name if you wish to, and you can add a label to the files that are going to be created here. So for example, we could put voice comment. Bearing in mind the dosimeter also is able to monitor when it receives a bump or a knock during the measurement. This is where we would set the sensitivity of the unit. The default value is 8G. This can be changed if necessary to account for the variation in the way that the worker might undertake their work during the day. Choose your operational screen language from the available ones shown here, and at the end of the measurement, when the dosimeter is stopped and you put it back in the case, if you forget to turn it off immediately, this is the time to automatic shutdown. After 5 minutes of non-activity on the keypad of the unit, when it's not measuring, it will automatically switch off to save batteries for you. These are all the settings in the General tab. Once we've finished changing all the things that we want in the General tab, we can go on to the next one, which is the Autorun tab. In the Autorun tab, there's just two sections, either to set pauses during the day, during the measurement, if we know when these pauses are going to be for breaks in the morning or a lunchtime or an afternoon break, we can select them on, and it's just simply a case of selecting the start of the break and the end of the break for each of these 5 potential pauses. And we can set the breaks accordingly. There we go. So we have set now 3 breaks, one for the morning for a 20-minute period, one for lunchtime for a 30-minute period, and one in the afternoon again for just a short 10-minute period. During these times, the instrument will stop collecting information and it'll just put a pause marker in the results. So these are easy to set up by just selecting them on and altering the times that you want. The other form of timer that we have is also potentially quite useful. This is a delayed start timer that can act at a particular day of the week and a regular start and end time for as many times as you want it to occur. So in this case now we're setting the instrument to measure Monday through to Friday, all 5 days of the normal working week, for 3 of those cycles, each day starting at 8 o'clock and going through until 4 p.m. So this is the setting for the delayed start timer. Let's just turn that one off now to keep things simple. These are all the settings for the Autorun control. Once we've finished all of the settings to do with the Autorun mode, the pause and the delayed start timer, our last tab is the recording tab. So let's look at this. For the dosimeters, this is split into 2 slightly different ways of collecting the information. We can either perform event recording or we can perform wave recordings. These are mutually exclusive. If you turn one on, you can't have the other one. The significant difference between them is that in the wave recording mode, files are saved separately from the data logged regular noise dosimetry results. In the event recording, the files that occur during the actual noisy event that you configure are stored within the data logger file and can be viewed and seen while you're looking at the sound level readings in the software afterwards. So unless you particularly want separate wave recordings, the best one to use is the event recording. The event recording is only available if you have the audio recording option fitted to your noise dosimeter, as this one does. So this one enables us to choose any of these methods of triggering and beginning the audio recording. We can select a continuous recording with a pre-weighting filter and a sampling frequency. The higher the sampling frequency, the higher the quality of the recording. 12 kilohertz, the lower sampling frequency, will give us longer recording time at the slight expense of quality, but certainly good enough to listen to and to be able to identify the events that occur. Rather than a continuous recording, which we really wouldn't want unless we have a particular reason to have an 8-hour full audio recording, we would normally want to use some form of trigger. So we have two methods of triggering, either using a slope with the sound level increasing or decreasing, or triggering at a particular level, again either positive or negative going. If we choose the slope trigger in the positive direction, first two choices are as we saw for the continuous recording, but now we get some extra choices here to be able to set the trigger level. Let's choose 90 dB since that's our 100% noise dose, and the trigger step is the interval at which the dosimeter will average out to detect the exceedance of this level. We can have a pre-trigger. This is a few seconds just before the trigger actually occurs, so you know what was going on before the trigger occurred, and then we can set a time limit, either no limit at all once the trigger is exceeded until it falls below that level, or we can set a fixed time interval, perhaps 15 seconds worth of recording when the trigger conditions happen. That's usually enough to be able to identify what happened, to listen to whether it's a fan or a pump or a compressor or something that you weren't expecting. So these are the settings that are available for us in the recording tab. Once we've done all of this, we've pretty much set everything that we need. At this point then, we go back to our local files list and we'll see that the setup that we've been altering and changing now has a small asterisk in front of the name. This indicates that the file has changes in that we haven't yet saved. So simply come down and click the Save button, and that will store the final copy on our hard drive. Now we just need to transfer that back to the dosimeter by clicking on this button between the two boxes. There's the basic setup configuration file now in the memory of the instrument, and having done that, we see that the last uploaded setting is indicated here. We just need now to make one final choice, that's to highlight it and apply this setup name, so that this is now the activated setup. This is the setup that the dosimeter will follow all of the instructions on how to make the measurements the next time it's switched on and a run is started. Now we can disconnect the dosimeter and we are ready to make our measurements. So I'm going to unplug the cable. Our dosimeter is now disconnected and we're ready to begin our measurements.